All right. I think I wanted to use volunteers for this one, but I wanted to use volunteers that haven't been up. Like we've had a lot of the same people going up. How about the gentleman with the young man with the undercut in the back? How about you? You haven't been up for any of these.
I haven't.
Yeah.
Okay. I'm like, it's not dangerous, is it?
Don't ruin your figure.
Perfect. Here, put these on.
It matches.
Alright, so the first part of this is exactly like you're going to use this to fight a fire. You break off the plastic seal, you pull the pin, and then at this point you'd aim at the base of the fire and squeeze the handle.
Oh my gosh!
The difference is that instead of aiming at the base of the fire to suffocate, no, it's gone already. What we're going to do is catch it in the sanitized cloth bag. Just cleaned it last night along with my lab coat. There's nothing extra on this lab coat. So what you're going to do is exhaust that into the bag. Okay? This is the part where you're wearing those gloves, because these gloves are going to keep your hands from. So I kind of wanted to do this part last bit, but I thought it might be more fun if you guys got to see the professor out there doing it. So what's coming out of there is dry ice. Negative 109 degrees Fahrenheit.
Oh my god.
This should be enough. All right. There. All right, can we have a round of applause for this? So,
Can I sit down?
sure. I'm going to pass around a little bit of this, what is now, it's very, very powdery dry ice. You guys, don't eat it pretty much. It's very, very cold. It's negative 109 degrees Fahrenheit, right? It's about as cold as winter has seen. So, actually, pass around some of this.
Yes.
It is sublime.
Very
right
cold.
now.
Oh my gosh.
Directly from a solid into a gas, which is why I said, don't worry about your bag, it's gone already. So, now we need the ice cream base of science. A little bit of extra right here just because I want to do it in a hurry. You're going to use 3/4 cup of sugar, 2 cups of heavy cream, 2 cups of half and half, 2 eggs, 2 teaspoons of vanilla extract, and a dash of salt. And I'm going to go through and do these again now, but the important part is that if you're adding sugar into something that is cold, it's not going to dissolve very quickly. So I've actually brought over, we use boiling water from this, what is it called? Teapot. Thank you. Alright. I'm going to do this in a couple minutes instead of. Alright, so I'm sure you've all seen something get mixed before. This is very impressive. I went and get a large punch bowl to do the mixing, but Google Maps does not understand a dollar store does not mean the dollar store in Chicago, Illinois, which is what I got every single time. All right. Every time. And then I ran out of time. I rewrote this speech 6 times. Even though I was never happy with it. I'm still not happy with it this morning, but I ran out of time, so. Shut. That is heavy cream. Sugar, a 5-pound bag like that is going to cost you a few dollars, maybe like $5, something like that. Each of these, the heavy cream and the half and half, both cost me $2 yesterday. The dozen eggs will cost $2, the vanilla extract a couple dollars, and you can use it a bunch of times. I'm actually only going to wind up using 2 eggs, so you can do this 6 times with the amount of eggs that I have today. part, how about some ice cream facts? The first frozen desserts, right, were, that we know about at least, were Persian Empire, 500 BC. So basically, people have been eating things similar to this for 2,500 years at least. The Chinese are believed to have, just discovered the idea of freezing things using salt and ice. And here's an important thing if you wind up doing this at home, is you can always add more dry ice to your mix. You can't take it out, and this is now subliming rather quickly, so if you put too much in, you'll wind up with your ice cream boiling over as it freezes. Who wants to mix this up for me? Sure. Just keep stirring that like you would anything. If you could take it around and allow people to see you stirring, it'll start getting low on the dry ice. Go back there. All right. So in the 1800s, the Arabs invented the more modern recipe, which is with milk and sugar. In the 13th century, Marco Polo brought it to Italy. The chef of Charles I of England actually was beheaded for releasing the royal ice cream recipe to the people. So that's how important ice cream was to some people. The Scottish colonists brought it in the 1700s to the US, and it was actually sent over as a morale booster during World War II to the Allied forces, which popularized it worldwide, and a lot of the world actually thinks that America invented ice cream because of that. Right, like I said before, I'm a science guy, so I'm going to let you know about the science as well. What's going on here is the physics, if you will, behind it came through. There's a bunch of laws, like gravity is a law. Boyle's law, Charles's law, Avogadro's law, and finally in 1834, Emile Perron or something in French comes up with the ideal gas law, which put all of these together and gave us something useful. We actually use this, you don't realize it, every day, because this is the same thing that's going on here, making this, is the way that your freezer or refrigerator works. And we'll explain what is going on there in a second. Okay, so what the ideal gas law has here is pressure, volume, and is basically just how much of the thing you have there. In this case, it is carbon dioxide, which is the same gas that you're all breathing out right now. R is, I'm just going to say, it's a little bit of magic that makes the whole thing work. It's just a number, but it's a very important number. And then temperature, since we're not actually going from that much, we're not changing the volume that much proportionate to what everything else is going on, we can ignore this. We're not making or creating carbon dioxide. This one is just something multiplied, like I said. So we're just looking at really pressure and temperature, which gives us the pressure is proportionate to temperature. That's what all of the R does. So what happens is that it goes from very high pressure in here to very low pressure in the room. Starting to get solid. The good news is that this part will clean itself up on its own. I brought a lot of paper towels just in case the ice cream actually did boil over. But sorry, I should have given you the parts. But I also want to make sure that it is ready to eat at the end here. I think that's actually all of the ideal gas law. Okay. It's not working. All right. Okay. Too slippery. All right. So we got a little sidetracked there, but the pressure drop from in here where you've got 5 pounds of carbon dioxide, which is an immense amount of volume. We're talking about cubic meters, cubic yards, whatever you want to look at. Large amount of space squishes down in there, which when you have it squished in there, it's under high pressure. So when it comes out, it loses all of that energy, right? And becomes very, very cold, which is why the volume doesn't wind up changing that much because the temperature has dropped so much. Okay. All right, so we went over where ice cream comes from, we know how it works, and we know how to make ice cream on days. One important bit that I almost left out when I was going over the prices. If you buy your own 5-pound carbon dioxide fire extinguisher, your initial investment will probably be about $60 for one of these, but then you can get it refilled for like $10 to $20. So, you know, you can do it like birthday parties, or if you go to a drinking party and the guy that shows up and makes carbonated ice cream at the party, then people are going to be like, it's the ice cream guy or the ice cream girl. They're going to be excited, you're always going to get invited, that kind of thing. And if you somehow manage to start a fire while making ice cream, you have a fire extinguisher right there. I kind of got sidetracked or not, but basically at this point, if anybody has any questions about how the pressure bit works or anything at all. No? Okay. Eventually this is going to freeze, but if you guys want to work on the review thing, I think that trying to do the question thing at the end is sidetracked everybody. No, still in one. I did my conclusion, asked if anybody had any questions, but I think that format threw everybody off. So don't do it next time.
Okay, let's give Liam some feedback here. What worked? The everything, right?
Well, there's some not frozen yet. Don't give me that much credit.
Tehran.
It was great. You made science. Actually, you made me want to learn science. Like I've hated science like all my life, and you made something like I actually want to look at and formulas and everything. I actually want to learn. So great job. I commend you.
Very good. Okay, good. And I like the whole science guy. You know what I mean? I thought that was really good. Okay. The fake bow tie's great. Okay. Amir. And we'll get you guys.
I think the last part in the fake tie, what really pulled me in was when you got the spray the thing, and I was like, oh, like I thought that was great. It pulled me in, like I could hear it, and I could actually see like the smoke.
And for what it felt great.
Yeah, my
It wasn't machine gun.
You were the perfect straight guy. You asked me if it was safe. I handed you the gloves. I brought a blast shield that was going to hold up for comic effect. I forgot that I had it.
I just have to point out the attention to detail here. Does this make sense? The pre-planning. He's had this topic from the get-go. This is what he wanted to do. All right. So the fact that you brought in all of this for today's presentation is really impressive. Okay, Zach and CJ and Alex.
I did like the continuation of paper props. Because
Yes.
you did that in your last week. I thought that was great.
That's great.
I hope you continue to do that.
They're not gimmicks. They're kind of fun, and you can get away with them. You know what I mean, I don't know if everyone can do this.
Well, it gave him the Bill Nye effect today.
That's great.
Which was awesome. And you were very informative. You clearly knew everything you were talking about. As this year, you kind of have to.
Like I said, I mentioned I wrote the speech like 6 times because I kept not being happy with it. And then last night I forgot my final copy at home, so then I had to rewrite it again so I could practice it.
You were doing something scientific, but you were still conversational about it.
Right.
You made it really casual.
Right.
Which was great.
Right. Maybe going back to what Tehran said too. I just have to point out the teacher. I mean, he came in on time with this. Do you see what this could have been 3 hours? You know, this could have seriously run over time. So your editing was really remarkable for this process. CJ and then Alex.
So believe it or not, this is the 3rd time I've seen this done in the past couple months, and yours has been the best because you use humor, and like
The humor is great.
the humor is really well paired with like the information that you're providing, and I think you just have a really great personality and atmosphere.
But it's your type of humor too. If you remember Liam's first speech, the sarcasm. Sometimes I don't like when people speak under, use the sotto voce, they speak under in an undertone. But sometimes you drop your pitch and it's funny, and I think that really works nicely because it's your kind of ironic, sort of silly, may I say it, nerdy science guy humor, okay? Which is cool, okay? Okay, Alex?
I mean, it gave you the persona, like Zach said, of Bill Nye, and it was very interesting to watch. I mean, it was hilarious. You gave the bowl to somebody, and she went around and she showed everybody. So it was like fantastic class participation there. It was like a really good idea. And then I hate science personally. I'm sorry. I'm like an artsy kind of person. So I saw that and I was like, oh no. And then you finished it and I was like, oh okay, it was painless.
Yeah.
It was painless.
Doesn't this car remind you sort of a teacher's you maybe had? That wheel, I'm like, oh, okay. You see the car coming in and it's going to be a lesson. Yeah, but I thought it was great. It's great. Anybody else?
I thought it was great, like all the century you talk about. It was great vision, with the smoke coming out when you were squeezing it, the smoke coming out the bowl from the freezing, and the sound.
No, the vision, the sensory appeal was great. It really, really was. In terms of
I put more, so it's like really.
And in terms of the assignment too, both the timeline was great, the historical facts, and then also the science facts were great too. I thought that was really, really interesting. The use of the board, look how simple that is. And I like the one letter, that's the magic, okay? So things like that were really, really fun and informative at the same time. I thought was really good.
There's like an hour just on this thing. It has the weirdest units ever, like not meters per second. It's like liters atmosphere per like something.
I feel very abstract PR there, so you're losing.
Temperature square.
Oh, I am a scientist. I was wondering what your green pins.
Oh yeah, this was from the science fair last year. It's actually my wife. She's actually she just got, kind of like 3 days ago that she got a job. She's going to be the genetics professor at George and Cork University, New Jersey. So that's very exciting.
You can be the guest lecturer there, right? Yeah. I need to point out something too in terms of what public speaking she should do. You guys think of this, the internal summary. If you notice, now that we learned this and we know this and we learned that and we learned this, and then he moved on to the next thing that we were to learn. Okay? So remember to do that along the way. It's called an internal summary, and I thought that was great.
Yeah, everything laid out nice, and you give a price for pretty much everything.
Yeah.
Which is cool.
Yeah.
Something that you can do at home.
Yes. Yeah. And you'd be that guy at the party, right? Alex?
This might be a little weird, but I actually liked the fact that it was messy and it just kind of went everywhere. And then it was self-cleaning at the end.
Yeah.
It was great. It was like you just watched it evaporate on the ground. It was
Well, that's like a science experiment, sort of. Well, like a science experiment, sometimes some of this is left to chance and you're not quite sure. I thought that really, really worked. And generated a little bit of suspense even. I don't know, I thought that was cool. So.
Yeah, when you picked that thing up and it was like...
Oh no, that was awesome. that was great. I just want to get one for home.
like every time your dog does something.
No, or my beta. I'm more of a beta. Okay, is there any room for improvement?
Yes, they could get the ice cream.
This was awesome.
It was awesome, but go ahead. CJ.
This is just the middle,
And we probably have to get out of the room so I
But
think French class is fine.
because you had so much to do, like you were so active and moving around, there was a little bit of time when you just weren't saying anything. Just like, oh yeah.
That's the only thing I would say too.
Just on characters who come to your speeches. So.
But do you see where he's responsible for so many materials that you can see that there? But I think maybe if you did this again, that would not happen. Okay. So I think he's scooping out ice cream for us. Ari, is it for ice cream or? Okay. I don't see what time it is.
It's 1:42.
Oh, okay, then they're probably.